Hello everyone. In the last video, we discussed utility functions. We first show how we can relate our preferences to utility functions, or to say what it is meant by a utility function to represent a preference. We then discussed some properties of utility functions: the marginal utility, the indifference curve, and the marginal rate of substitution. The example I used last time, u equals to the square root of x times y, is a special preference that we are going to cover today. So in today's video, I'm going to introduce to you three types of special preferences that we think they have some nice features in explaining some of our real-world problems. The three special types of utility functions are: first, perfect substitute; second, perfect complement; and the third, Cobb-Douglas. The utility function u equals to the square root of x times y is a special case of Cobb-Douglas utility functions. And lastly, we will discuss some of the properties of those three special types of utility functions. So let's suppose you derive utility from two goods, Pepsi and Coke. So for some people who may have strong preference of one over the other, you can use the other examples, such as some tech products like thumb drives and RAM produced by different manufacturers, or some commodity that has a single purpose, for example, A4 paper and pencil, produced by different companies. We view those goods produced by different companies as perfect substitute, like Pepsi and Coke. The last one may be less true for more people, that coffee and tea may be viewed as perfect substitutes by some people as well. So the idea is that for people who derive utility from consuming Pepsi and Coke, 1 unit of Pepsi or 1 can of Pepsi can be perfectly substituted by 1 can of Coke and vice versa. Each unit of them provides us the same level of utility. For this kind of relationship between the two goods, we call them perfect substitutes, and we have a general form of utility function for them. So the general form is that uxy equals to ax plus by for some constant a and b, positive constants. So how do we find the coefficients a and b? These two parameters or coefficients reflects at what rate can we substitute one with the other. So in the Pepsi and Coke example, we can substitute 1 Pepsi for 1 Coke. So we can say A equals to B equals to 1 in this case. And more generally, this is a kind of tricky part. So there are two ways of saying this. The first is saying that if each unit of good X provides P units of utility, and each unit of good Y provides Q units of utility, and those two are perfect substitutes, then the utility function can be written as uxy equals to px plus qy. So basically, each unit of x provides p units of utility, so the total utility provided by consuming x unit of good x is p times x. And similarly, the total amount of utility provided by consuming q units of good y is q times y. And the total utility provided by consuming p units of good x and q units of good y is px plus qy. The second way to describe two goods that are perfect substitutes is by saying that, well, if m units of good x can be substituted by n units of good y, in this case, we should flip the order. So the utility function can be written as u equals to n times x plus m times y. And you have to think carefully when you see a question regarding perfect substitute, and make sure you get the coefficients correct. I'm going to draw the indifference curves for perfect substitute in this slide. So on the x-axis, on the horizontal axis is our grid x, and on the vertical axis is our grid y. Now let's see if we want to draw the indifference curve for the level of utility u equals to 1. This is basically 1 equals to x plus 2 times y, right? So we are drawing the curve for this equation 1 equals to x plus 2y. To draw this curve, there's a simple technique. So let's see if x equals to 0. When x equals to 0, we can solve for this equation and find that y equals to half. And similarly, when y equals to 0, we can solve this equation and find that x equals to 1. So this gives us 2 points. When x equals to 0, it is on the y-axis. Y equals to half means that, say this point is half. And so it says that this straight line passes through this point. And similarly, when y equals to 0, it is on the x-axis. X equals to 1 tells us that it goes through this point, x equals to 1. And we know that this is a straight line. So a straight line connecting those two points is the indifference curve that we are looking for. And let me use a different color. So this is the indifference curve u equals to 1 for our utility function u equals to x plus 2y. We can do a second one, that is u equals to 2. And basically, we are drawing 2 equals to x plus 2y. We are drawing this line, right? Using the same technique, when x equals to 0, you can find that y equals to 1. And when y equals to 0, you can find that x equals to 2. We are solving equation here. Based on this information, we know that when x equals to 0 on the y-axis, y equals to 1, so it passes through this point, 0 and 1. And when y equals to 0, x equals to 2, so let's say this is 2, it passes through this point, 0 and 2, on the x-axis. The indifference curve is then going to be a straight line connecting these 2 points. So this is the indifference curve for u equals to 2. Now you can probably see or imagine that those two indifference curves are parallel to each other, and they have different intercepts. They have the same slope but different intercepts. So we can draw more of the indifference curves. I'm going to save all those steps, but draw another one. That is u equals to 3. That is probably going to look something like this. over here. So the indifference curves for perfect substitutes are straight lines that are parallel to each other on the graph. And the slope of it depends on the ratio of the coefficient. So here, our coefficient is 1 and 2. If the coefficient changes, the slope of the indifference curve will become different. All right, so this is the indifference curves for perfect substitutes. So here is a practice question. This is not for extra credit, it's just a practice question. You should pause here, read the question and think yourself. So I will read the question for you here. So imagine Sally gets twice as much utility from consuming coffee as from tea. For her, coffee and tea are perfectly substituted. Which of the following could describe the utility function of x and y for Sally? And we have 4 options. So I will pause for 10 seconds. You should pause and think for however long you need to figure this out. And after 10 seconds, I will start explaining the answer to this question. All right, so the correct answer to this question is A, u equals to 2x plus y. So basically, Sally gets twice as much utility from coffee as from tea. So let's suppose each unit of tea gives Sally 1 unit of utility. Then each unit of coffee would give Sally twice as much as that, which will be 2 units, right? So that's basically saying by consuming 1 unit of coffee, Sally can give up, or Sally can, so consuming 1 unit of coffee can be substituted with consuming 2 units of tea and vice versa. And if you go back to the previous slides, looking at the statements we made, you can figure out that the utility function is actually described as u equals to 2x plus y. And the other 3 choices, B, C, and D, are all incorrect. The next type of special preferences we're going to talk about is perfect complement. So this is also a very interesting case. So suppose you derive utility from 2 goods, and here we are separately talking about a left shoe and a right shoe. And we all know that shoes have to be worn in pairs. And some other examples is like cereal and milk that you eat for breakfast, and bicycle frame and bicycle tires that has to be consumed at fixed proportion. And I will first draw the indifference curves for the perfect complement, and I will then show you the general equation for that. So let's say we are deriving utility from a left show and a right show. And as always, let's draw the indifference curve here. Let's draw a horizontal axis that is for left show and a vertical axis that is for right show. This is a left show, and this is our vertical axis that is for a right show. And well, we do not know the utility function or anything. Let's start from just a single point. Let's start from this point, 1, 1 over here. This is the point where the consumer consumes 1 left shoe and 1 right shoe. It is exactly 1 pair. So the consumer has a pair of shoes and she can wear it. Now let's suppose instead of having 1 left shoe, you get 2 left shoe, 2 left shows and 1 right show. Well, you have an extra left show, but you still have only 1 pair of shoes, right? You are not any better off as compared to when you have 1 left shoe and 1 right shoe. So this point, so if we call this point A and this point B, we would imagine that a consumer have the same level of utility at point A and at point B. And similarly, if we keep giving the consumer more left shoes, well, she can still always only form a pair of shoes, and all the extra left shoes she obtained does her no good. So overall, any point on this horizontal line gives her the same level of utility. She can only form 1 pair of shoes and no more than that, regardless of how many more left shoes she has. Similarly, any point on this horizontal line here, she has only 1 left shoe, but she is having increasingly much right shoes. She can still only form a pair of shoes, and all the additional right shoes she has does not make her any better. Does not make her any better off. And remember the definition of indifference curves. The indifference curve is the collection of points that gives the person the same level of utility. And here, every point on this L-shaped curve gives her the same level of utility that she has when she has only a single left shoe and a single right shoe. Every point on this L-shaped curve, she can only form a pair of shoes and will derive the same level of utility. So this is the indifference curve. Of course, we do not know the level of utility of it yet, but we know that every point on this curve, we know that every point on this curve gives her the same level of utility and therefore must be on the same indifference curve. We can make similar arguments at other points, and we can know that this is another indifference curve, and that this is another indifference curve. And what is special is that this point passes through, well, it's not well drawn here. It doesn't actually pass through the same line. But let's imagine this point, they are on the same line, which is y equals to x. So this orange line is not an indifference curve. But it is the line at which the point A, the red point, and the green point must be on. And all those L-shaped curves are the indifference curves. All right. So this is the graph for perfect complement. Next, in the next slide, I'm going to show you the general form of how we represent it mathematically. So the indifference curves for perfect complements are all L-shaped. The general form of the utility function takes this form, u of xy equals to the minimum value of ax and by, where a and b are some positive constants. And this minimum function, if you are not familiar with it, it is basically equates to the smallest value of all its arguments. in this case, we have only two arguments. So it equals to ax if ax is no larger than by, and if it equals to by if by is smaller than ax. And we want to note that the marginal rate of substitution is not defined for this type of utility functions, because the utility functions is both because there is no substitutability between the two goods, and also the marginal utility are not defined. We are not deriving any additional utility if we marginally increase the consumption of a single good holding the other constant, right? If we increase our consumption of a left show holding our consumption of the right show constant, well, the increase in our utility is undefined. So perfect complement, there is no substitutability between the two goods. Both the marginal utility and the marginal rate of substitution is not defined. So the next question is, how can we find the coefficient A and B? So here is a common rule. So if the proportion or if the rule that we consume the two goods are such that m units of good X must be consumed with n units of good Y, then we should flip the order. We should put n in front of X, and we should put m in front of Y. So uxy is the minimum of n times X and m times Y. So in the example of shoes, well, we are pairing one left show and one right show, so the coefficients are 1, 1. If we are consuming 3 units of cereal with 1 unit of milk, then we are putting 1 in front of cereal and we are putting 3 in front of milk. And lastly, if we are combining one bicycle frame with 2 bicycle tires, then we are putting 2 in front of the bicycle frame and we are putting 1 in front of the bicycle tires. The third type of special preference is Cobb-Douglas. And this, as I was saying, the utility function that I used as an example last time is a special case of Cobb-Douglas utility function because it has some very nice features. So the general form of Cobb-Douglas utility function is that u equals to x to the power of alpha times y to the power of beta for some positive constants, alpha and beta. When alpha and beta are both 1, u equals to x times y. When alpha and beta are both equal to half, u equals to the square root of x times y, which was the example we used last time. We can also derive the marginal utility of this special preference. So the marginal utility of x is alpha times x to the power of alpha minus 1 times y to the power of beta. And the marginal utility of y is beta times x to the power of alpha times y to the power of beta minus 1. Both of them are positive, and here we are applying the partial derivatives to our utility function. If you have, I'm not discussing this in detail here. I skipped many steps. If you have problem with how we calculate or how we derive those two expressions, make sure you come to my office hour and ask me, and I can go through that with you. So both of the marginal utilities are positive, so it satisfies the assumption that more is better. And lastly, we can also derive the marginal rate of substitution of x for y. We derived the equation that we can use to calculate this which is the negative of the ratio of our marginal utility of x to marginal utility of y. And if we substitute the expressions into it, we can find that the marginal rate of substitution of x for y for a Cobb-Douglas type utility function is negative alpha times y divided by beta times x. And always remember, alpha and beta are just some constants which you will be told in the question you see. And we also see that this marginal rate of substitution of x for y depends on both the amount of X and the amount of Y that we are consuming. So in the next slide, I'm going to show you the indifference curves of Cobb-Douglas utility functions. It is not easy to draw with hand, to draw it precisely, so I draw it on a computer and I took a screenshot of it. So here we are looking at the indifference curves for the utility function u equals to x times y. And we are showing 4 indifference curves, u equals to 1, u equals to 2, u equals to 3, and u equals to 4. We can see that they are not parallel to each other. The one that has the lower level of utility is closer to the origin, and the one with higher utility is further away from the origin. They are not parallel to each other, but they never intersect each other, right? And I only draw 4 of them, but as I mentioned last time, there are infinitely many indifference curves on this graph that can be drawn. So you can do u equals to 1.5, which will be an indifference curve looking somewhat similar, but in between the curves of u equals to 1 and u equals to 2. You can also do u equals to 1.1, etc. There are infinitely many of such indifference curves. And lastly, I draw 3 straight lines that are tangent to the indifference curve u equals to 1 at different points. So firstly, the steepest one is a straight line that is tangent to u equals to 1 at the point 0.5 and 2, and it has a slope of -4, which we can calculate using the formula which is derived in the previous slide. Remember, the MRS equals to negative alpha times y divided by beta times x. We can use that formula to calculate the slope of the indifference curves at different points. And the red line has a slope of -1 and is tangent to the indifference curve at 0.11. And then lastly, the most flat indifference curve has a slope of -0.25, and it is tangent to the indifference curve at the point 2 and 0.5. So we can see as the value of x increases, the absolute value of the slope of the indifference curves, which is the marginal rate of substitution, becomes smaller and smaller. So the Cobb-Douglas type of utility functions satisfies the diminishing marginal rate of substitution, and this is an example of it. So at the end of the last video, I was trying to draw how the indifference curves will look like when the marginal rate of substitution is diminishing. And I didn't do a very good job there, but in this graph, I hope it becomes clearer to see this point. So this is some indifference curves for this specific utility function u equals to x times y. When you change the value of alpha and beta, the shape or the position of the indifference curves will change, but overall it will look something similar to this. So lastly, there are some properties of the 3 special preferences or the 3 special utility functions that we have discussed today. First of all, for perfect substitute, the general form is that u equals to ax plus by. And we can, well, take the partial derivative pretty straightforward here, and we can find that the marginal utility of x is a, and the marginal utility of y is b. The marginal rate of substitution, which is the negative of the rate of mux divided by muy, is going to be negative a divided by b. And all those are constants. So for perfect substitute utility functions, it does not exhibit diminishing marginal utilities for both of the good. It also does not exhibit diminishing marginal rate of substitution of x for y. All those, it has constant marginal utilities for both goods, it also has a constant marginal rate of substitution of one good for the other. This is perfect substitute. For perfect complement, both the marginal utilities are not defined because we cannot take derivatives of this function. And also, the marginal rate of substitution is not defined. Firstly, because the marginal utilities are not defined, but also because there is no substitutability between the two goods at all. So the MRS is also not defined. And lastly, for Cobb-Douglas type of utility functions, we derived the marginal utilities, which are both positive, and we showed in last week's video that when the marginal utilities are both positive, the indifference curves must be downward sloping. It is one of the properties of the indifference curves. It has a marginal rate of substitution that is negative alpha y divided by beta x, and the absolute value of this expression is decreasing as x increases. So the Cobb-Douglas utility functions has this nice feature that it exhibits diminishing marginal rate of substitution. And as an implication of diminishing MRS, the indifference curves will be bowed in towards the origin, like what we see in the graph. So lastly, let's summarize what we taught in this video. So we have a general form for perfect substitutes. The indifference curves are parallel straight lines with the slope equals to the marginal rate of substitution, and this slope depends on the ratio of A and B. We have the perfect complements taking the form of U equals to the minimum of AX and BY. The indifference curves, as we draw, are L-shaped. And for the perfect complement, this utility function, both the marginal utilities and the marginal rate of substitutions are undefined. We showed how we can translate from text or statement to mathematical representations, and how can we find the correct corresponding coefficients A and B in cases of perfect substitute and perfect complement. Lastly, we discussed the Cobb-Douglas utility functions, which is in the middle. There is some substitutability between the two goods, but they are not perfect substitute. The MRS is going to change as X and Y changes, and it also depends on the value of alpha and beta. The indifference curves are downward sloping and bowed in towards the origin. And the Cobb-Douglas utility function also exhibits diminishing MRS. This is all for chapter 3. After watching this video, you should go to iLearn and try to finish the homework on the iLearn. So see you next time.